Welcome back to YouTube channel Mechanical Study. So today we're going to start with our question bank series for subject fluid mechanics, and these are all the questions will be helpful for you all to crack SSC JE, RRB JE, then GATE, then engineering service exam. So here we'll start with the question number 1. Here question number 1 is: a fluid is a substance which offers no resistance to change of. Options are pressure, flow, volume, shape. So here correct option will be option D. As you all know that a liquid is a kind of a substance which will occupy a space or occupy a shape where you pour it in it. So here if you pour a liquid in a glass, it will take a shape of a glass. If you pour a liquid in a jar, it will take a shape of a jar. So here correct option will be D, that liquid will not resist any, or it will not offer any resistance to the shape. So option D will be the right answer. Which of the following has no unit? So options are surface tension, which unit is Newton per meter or joule per meter square also. Then next, kinematic viscosity, again it has a unit, that is meter square per second. Then strain, that is it has no unit, so it is unitless quantity. So option C will be the right answer. And strain is nothing but the, basically there are two types of strain, that is longitudinal and lateral. So we'll see in detail in some subject, but here strain is nothing but the change in dimension to the original dimensions. If you consider a length, then change in length to the original length. So here strain has no units. Again bulk modulus also has a unit, that is that is a, its formula is normal stress to the volumetric strain. Okay, so let's say its answer will be the option C. So move further. Which of the following sets of condition clearly apply to an ideal fluid? So what is ideal fluid? The basic difference between ideal fluid and real fluid is that ideal fluid which does not exist, and a real fluid which has a viscosity and which exists. So first of all, ideal fluid which has no viscosity, that is it is a non-viscous. So here the option that is in option B and option C, that is given that ideal fluid where it is a non-viscous. So either of the option B or option C is clear, is right answer. So here second property of ideal fluid, that it is incompressible. Incompressible means what? Its density remains constant, or it cannot be compressed. So here in option C, sorry, that is in option B is incompressible, means it will not be, its density will remains be constant. So here option B, where the ideal fluid is nothing but non-viscous and incompressible. So non-viscous means it has no viscosity, that is it will not offer any resistance to the flow. And secondly, incompressible means its density will remains constant throughout the flow. So here option B will be the right answer. But ideal fluid is the fluid, as the name suggests, that it is not actually, it is a hypothetical fluid. Here option B will be the right answer. Then specific gravity of mercury is, so here density of mercury is 13,600 kg per meter cube. So its specific gravity will be the density of mercury to the density of a standard fluid, that is water. So it is comes out to be 13,600 divided by 1000, so it comes out to be 13.6, and it has no unit. So the specific gravity of a mercury is 13.6. The next question: the viscosity is a property of fluid we hold due to. So here options are resistance offered by layers of fluid, that is the right answer. Here option A will be the right answer. So what is viscosity? Whenever there is flow of fluid takes place, there is a resistance offered by the one layer of a fluid on the another layer. Means if this layer is flowing with the velocity of v, so another layer will exert some resistance to this layer, and that property of a fluid is called as a viscosity. The next question, that is Newton's law of viscosity, states that, so according to Newton's law of viscosity, that is tau is directly proportional to du by d by, tau is equal to mu into, that is a, this mu is nothing but the dynamic viscosity into du by dy, where du by dy is the velocity gradient. So here shear stress is directly proportional to velocity gradient, that is given in option B. Okay, so shear stress is directly proportional to velocity gradient, that is all given in option B. So here option B will be the right answer. Then next question, rate of deformation of a fluid element is equal to. So rate of deformation of fluid element is equal to, the question is that. So here for that purpose we need to know about the Newton's law of viscosity. Again, rate of deformation of fluid, that is also we should know that that is the, again it is nothing but d phi by dt, or it is a nothing but a shear strain that is indicated by pi. So here this will be directly proportional to fluid element is equal to, so it is equal to the velocity gradient. That means this du upon dy can be written as d phi by dt. It is nothing but the shear strain. So here this will be equals to velocity gradient, that is given by option D. The next question, the viscosity of liquids decreases with increase in temperature due to. Now here what happens when we increase the temperature of a liquid, is increases. During that case what happens, suppose this is a liquid, if you try to increase the temperature of a liquid, then the intermolecular force of attraction between the two liquids goes on decreasing. That is the cohesive forces, that is the forces that is act between the same molecules of a liquid. So this bond will be break, that is the intermolecular force of attraction between the any two molecules will be decreases as its distance from each other goes on increases as temperature increases. So here, so correct answer will be the decrease in cohesive forces. So option A will be the right answer for the question. A reason behind that is the, as the temperature of a liquid increases, distance between two fluids will get decreases. The reason behind that is the intermolecular force of attraction between the molecules of a liquid will get decreases, and hence the cohesive force, that is a force which is act between the between the molecules of same liquid, that is for that force is called as cohesive force. Then another force that is act between the particles of two different fluids, that is called as adhesive force. The next question, falling drops of rain acquire spherical shape on account of, so without doubt answer will be a surface tension. So surface tension is that property of a fluid which form a stretch membrane at the top of a liquid. If there is a liquid, so here surface tension is nothing but, so here if you take an example of a surface tension, so surface tension is nothing but the, it is property of a liquid or a fluid, which will form a stretch membrane at the top of a liquid. Means if there is a liquid in a bucket, so here at the top it will form a stretch membrane. That property of a system is nothing but the that is a surface tension, and unit of surface tension is either Newton per meter or joule per meter square. So next, that is so here option B will be the right answer. The next question, if sigma refers to a surface tension of the water, rho refers to a mass density, g refers to the gravitational acceleration, d refers to diameter of glass tube, then capillarity rise of water in glass tube is given by. So here without any doubt a formula is, that is 4 sigma cos theta upon rho g d, but here given is that the water is given, so for water theta is 0 degree. So here if you immerse a small diameter tube, which is also called as a capillary tube, so whatever the rise in water level or rise in water level in a capillary tube when you dip it into fluid. So that is given by 4 sigma cos theta upon rho GD, where sigma is the surface tension, theta is the angle that is made by the fluid which is in the capillary tube with the normal, that is a vertical axis over here. Rho is the, that is the density, G is the acceleration due to gravity, and D is the diameter of the capillary tube. So here option that is C will be the right answer, that is 4 sigma upon rho GD as cos theta, that is theta is equal to 0, so that is cos theta will be equals to 1. What happens, next question, that is what happens to the liquid level when a small diameter tube is inserted into liquid whose contact angle is 125 degree. Okay, so there are two angles that is formed by the liquid. The contact surface of a capillary tube, first is the acute angle, which is nothing but angle less than 90 degree. So here there will be a rise in rise in liquid in the water when we dip a capillary tube into a fluid. Okay, so such for example of such fluid is nothing but a water. So water is an example of such fluid where there will be a rise in water. Then next is the, that is when theta is greater than 90 degree, that is theta is obtuse. So in that case there will be a fall in water fluid level in a capillary tube. Okay, so there will be fall in that is a fall in fluid in a capillary tube. So in those case the angle, that is theta is obtuse, that is greater than 90 degree. So here correct option will be liquid level will falls. So here option B, that is liquid level in tube, also option B will be the right answer. Now for apart from that, whatever the fluid where its contact angle is less than 90 degree, that is a acute angle, those fluids is also called as a wetting fluids, and those fluid where the contact angle is greater than 90 degree are called as non-wetting fluid. An example of those are mercury. The next question, inside pressure of a hollow bubble of diameter d subjected to surface tension sigma is given by, so here correct option will be the, that is option B, that is P is equal to 8 sigma upon D. Similarly for a drop, that is for a water drop, it is 4 sigma upon D. For jet which is coming out of a nozzle, that is 2 sigma upon D. For air bubble it is 4 sigma upon D. So here for a given question, that is correct answer will be 8 sigma upon D. So here option B will be the right answer. The next question, in exam also question may be asked for a water drop. So for water drop, inside pressure will be 4 sigma upon D. Next question, the viscosity of water is respect to air is. So here water, we have to compare the viscosity of a water with the viscosity of a air. So here, as you all know, that the viscosity of water is more than the viscosity of air. So the higher the viscosity, the more the resistance of a fluid to the flow of a fluid. Okay, so here the for any fluid which is having higher viscosity, it will resist its flow. So as compared to the air, water is more water has more viscosity, and it is approximately equals to the 55 times the viscosity of air. So here option B will be the right answer. Next question, pick the correct statement about viscosity. So options are, option A, in general it decreases with temperature for liquids because internal force of attraction between two fluidless gets decreased. So here option A is correct. That is the for a liquid, as temperature increases, the intermolecular force of attraction between the molecules goes and decreases, and it's because of which the viscosity also decreases for a liquid. The next question, the bulk modulus of elasticity with rise in pressure. So for formula of bulk modulus of elasticity is nothing but that is, it is represented by K is minus V dP upon dV or rho into dP upon d rho. So here question is that bulk modulus of elasticity with rise in pressure means if you rise the pressure, that is we have to compress the substance. That is here in order to rise the pressure we need to compress the substance. Okay, so there will be, as you try to compress the substance, so its density will goes on increasing. So here whenever we rise the pressure, the bulk modulus will also increase. So here option B will be the right answer because its density will increases, and density is directly proportional to bulk modulus. So here bulk modulus will also increase for a given substance.